Hey, welcome back to RamZland. Today I want to show you an easy way to measure the force of buoyancy. Check this out. In this investigation, I'm using my metric scale, a beaker of water, some metric weights, a rubber band, and a dry erase marker. Start by marking a line on your beaker to indicate where the water level is right now. The next step is to choose the weight that you want to test. I'm going to test 30 grams. So right now my scale reads 228.30 grams, and that's the combined weight of the water and the glass beaker. Now I'm going to lower my weight and just let it rest on the bottom, and it's up to about 250 grams, 251 grams, which is what we would expect. Now I'm going to do something different. I'm going to lower the weight in the water, but I'm not going to let it touch the bottom of the scale. And you would expect that there wouldn't be a change because the weight isn't touching the bottom of the scale. Watch what happens. 228 right now, and it's going up. Even though the weight is not touching the bottom of the scale, it went from 228 grams up to 236 grams, and it's not touching the bottom of the scale. How is that possible? Here's a closer look. So here we are at 228 grams. Notice that the weight does not touch the scale. It's only about halfway in the water, and I'm up to 235.88 grams. 228, and now the weight is going to increase even though it's not touching the scale. What's causing the weight to increase? I like this investigation because it helps illustrate the Archimedes principle, or his principle of buoyancy, which simply says the weight of a fluid that's displaced by an object is equal to the force of buoyancy acting on that object. And so when we lower the weight in the water, it displaces a certain amount of fluid. But if I don't let the weight actually touch the bottom of the beaker, the force of buoyancy acting on the weight has an opposite and equal force acting on the bottom of the scale. And that's why the scale reads that the water weighs more, because of the buoyant force pressing not just against the bottom of this weight, but the opposite and equal force pressing on the bottom of the beaker. Really cool and easy to test at home. Archimedes was a Greek scientist who worked a long time ago for the king of Syracuse, who was given a golden crown. The king suspected that it wasn't solid gold, but that it was made of a gold and silver alloy. And so he asked Archimedes to find a way to prove that the crown was made of solid gold without damaging it. And Archimedes, while taking a bath, realized that the water level of the bathtub rose as he climbed inside. And he postulated that the weight of the water that was displaced was equal to the buoyant force on the object. And so if you displace, for instance, a wooden block in a tank of water, you'll notice that the block rises again. That's the buoyant force acting on the block. But you'll also notice as you press it down that the water level rises. That's the amount of fluid that's displaced by the object underwater. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.